All right, we're going to take a look at some properties of the triangles. Now, they have median of a triangle, centroid of an angle. These are things that you probably have never heard before. So what I want you to do is make sure that you copy down this triangle with the marks into your little book. I'll give you a few moments to do it. All right. When we're talking about the median of a triangle, it's the segments whose endpoints are on the vertex of the triangle and the midpoint of the opposite side. So median goes from here down to here. Again, midpoint. So it's going to cut this exactly in half. Now you'll notice that they actually intersect in one place. This is called the centroid of the triangle. It's the point of where the three meet. It's also called the center of gravity. Okay? So this also needs to go there. So please make sure that you get this written in there as well. All right. The basic idea here of this one is whatever the segment is that you've identified for all right, now back. What you'll notice about this is that the centroid is going to be located 2/3 the distance from each vertex to the midpoint. So on the medians that you identify, the distance from B to P, A to P, C to P, that is going to be where the centroid ends up being located at. It's always going to be 2/3 of it. So I want to go and find out where the centroid is going to be here. Now, it says the distance from L to A is 12. Now, the rule said it's got to be 2/3 of that, correct? So it's going to be multiplied by 2/3. Not a big deal. That goes to that. Goes to 4. 2 times 4 is 8. So that means that the distance from L to O is going to be what? 8. Okay? So LO is going to be equal to 8. No, I mean that comes from this idea here. That is just where they meet. So proving it, that isn't part of what's going on. It's what we've defined it as such, and the only way to prove it is to go and take a triangle and draw out where they are at. So there we go. Not too bad. So let's find the centroid on a coordinate plane. Now again, what we need to do is make sure that we identify where the medians are going to be. Now for this one, what we need to try and do here first, we're on a coordinate plane, is identify where the midpoints are. So if you take a look at this, we got our corner here and here. It goes up 1, 2, 3, 4 over 1. So that means it should go up 2 over a half. Okay, midpoint is there. Up 2 over 1, 2, 3, 4, so that means up 1 over 2, the next one. So if I wanted to find where it was here, that's going to be up 1, 2, and over 1, 2, 3, 4, 5, so that means it goes over 1, 2 and a half, up 1. So it hit it right there. Makes sense? So now what we're going to end up having to do here is we are going to find out where the median is going to be. So it goes here, and it goes there. Every time. That is how it always works. So, where's the median going to end, or the centroid going to end up being at? Well, it's going to be sitting right here. What are those coordinates? Well, those coordinates appear to be -4 and 3. So we've got it at negative 4, comma 3. Okay. Well, the only way that you guys would have to do that would require a little bit more math than what you've got right now. So, I mean, from a grid here, finding the coordinate is what you're going to end up using. I mean, we can go through and set it up such that you identify the equation of the line, you find out where the lines go and intersect. That takes a little bit more. But that is another way of dealing with it. So, what I want you to do now is I want you to go and get a protractor. And then when you get back, make sure that you put this into your little book. All right, now we've got another one, altitude of a triangle. You have seen this idea before. I mean, after all, you needed to have something like that when we are dealing with the area of a triangle. Base times height divided by 2. The height always had to be at a right angle compared to the base. So, but we call this the altitude. Now, there's 3 sides to a triangle, so there's at least 3 different altitudes. That makes sense. Depending upon which way the triangle is sitting. You know, if the triangle was sitting on this side here, then this would be the altitude. If it was sitting on this side over here, then this would be the altitude. That's all that it's saying to us. You just got to picture that being changed around. Now, it says the orthocenter is the point of concurrency of the 3 altitudes of the triangle. So where these 3 altitudes meet, this is going to be another intersection that we're going to find. So, what I want you to do, now that you have the protractor, I want you to draw out 3 triangles. I want you to draw out an acute triangle, a right triangle, and an obtuse triangle. Then what we're going to do is I want you to sketch the altitudes of each triangle and find their orthocenters. Okay? And then answer the question, is the orthocenter always in the interior of the triangle? The nice thing is if you have, by using the protractor for this, you can draw yourself out 90-degree angles easily. All right, I've got my 3 triangles drawn out. So the next step in this would be to go through and put in the altitudes. So, now, like I said, the protractor comes in very handy for doing that. I can line the 90-degree line up on one of the on a base, and I can bring the straight edge side going up to the vertex. So I've got one in there, right triangle. Next one, right angle, I should say. go. So, see are they all lined up and hit for the acute triangle? They hit all in one spot, which is a good thing. Now repeat the process again with the right triangle. Remember, you are drawing an altitude, which is at a right angle from a base to the opposite vertex. And you're going to notice that you're going to have a wee bit of a problem trying to draw that on a right triangle. Not so much because you can't, but because they're already there. If I take a look at this, from this side to this vertex over here, I was able to put in a right angle, draw a line to it. From this vertex down to this side here, the only place where the right angle is going to be at is right there. Likewise from this one. So where we ended up having the orthocenter up here, inside the triangle, on a right triangle, it ends up being the vertex of the right angle. Now, the obtuse triangle even turns out stranger. This one is pretty easy to deal with. So I go from this side down to that vertex, right angle. What? No, not for this. Midpoint is only if you're doing the other one, okay? Then you have to find the midpoints. This is drawing a right angle to a base. So you've got two possibilities. You're either identifying the midpoint, and then once you got the midpoint, then you go from the midpoint to the vertex for a median. Or you go from a given base to a vertex and draw in a right angle. That is going to be the height. So if this triangle was sitting on this, that would be considered the height. Now, you've had to find the area of triangles that are obtuse, and you've seen heights do this. Mind you, I'm drawing on that line here, and here's where this comes down. So it's at a right angle here to something that continues on here. Now, I said these things were supposed to meet, right? Well, if these two are going to meet, it looks like it's going to meet someplace down over here, right? So I'm just going to extend this line out here so that I can see just how far it actually goes. I'm going to do the same thing with this one here. Let it extend it out, see where it ends up. We still got to go quite a ways down yet, right? So I've also got to make one off of this to this corner here. So what I end up having to do, draw the line down here, keep going, keep going, keep going. Now I've got 90 degrees from that line, which ends up right down there, but I got it extended out. It has to keep going. So I got to keep going. Hit that one there. Now I'm getting off here a little bit, isn't it? Because I gotta have a drawing in here. Oh. So that thing has an orthocenter that's way down here. So do you see how the process is for drawing them out, for those of you that actually drew them out? What do you mean you didn't draw them in a straight line? You can't draw them wherever on the paper. Huh? Yes, I did. I said you have to draw them so that they are at a right angle to a base. Let's draw another one out. Let's do another obtuse. This. The acute angle, or the acute triangle one is always the easiest. It's the obtuse one that is by far more difficult. Okay. Do I have an obtuse triangle? Now, what we would normally do is when I've got my protractor, I'm going to lay it down so that the 90-degree line is on one of the bases. Then I'm going to adjust it so that the straight edge goes through the vertex. I now know that this is going to be at a right angle. Why? Because the straight edge here and this 90-degree line here are designed to be at a right angle. So I know that is where it's going to be. Okay? Now, the other two are going to be a little bit more challenging because you just can't draw them straight across. If I go and set my protractor down here, for those of you that are watching, on this base, okay? I need to go and line this edge up with that vertex. So I'm going to have to slide it quite a ways over, aren't I? I got to keep going. I got to keep going. I have to keep going. So now I'm finally there. Draw that line in there. Now you have seen this in your books when you're doing the assignments, and they have a little dotted line that comes out from here, and they draw a right angle in this. Do you remember seeing things like this? Yes? No? Maybe so? You don't ever remember having to find the area of a triangle and they tell you that's how the height is identified in the base? Hmm? Good. So, that is drawn there. If I want to do the exact same thing off of this, for this vertex, I again have to lay the protractor down. My 90-degree line is going to be on that side, and I move it down until I get to the vertex on the straight edge. So now I've got this line. And if I were to go and extend this out, this is at a 90 degree to that line there. See, we can't necessarily see that line because it's not there. It's not part of the triangle. So if I go back to this one that I drew here, and if I extend the line out, it goes through and intersects at that point. So that would be identified as the orthocenter of this triangle. That's the process and how it's done. So, all right, we're going to move along. Balancing an object. Now, it says the centroid, okay, of a triangle is a point where the triangle can be balanced on a point. Now, it says suppose a student wants to perform a balancing act with triangles as part of a challenge. Each of the triangles are the same size, and the three medians are 4.2, 7.2, and 8.1 inches long. What is the distance from each vertex to the centroid? Now that goes back to this right here. If I know the length of the median, I simply take 2/3 of it, and that will identify the distance that it is from the vertex. So, there you go. I've got 4.2 for the first one. What do I have to multiply it by? 2/3. So, 3 goes into here, and I end up with, well, that should be what? A 14, right? How many 3's go into 42? 14. But it's 1.4, so it's going to be 2.8. Little tricks for multiplication and division, aren't there? 7.2. It gets multiplied by what? 2/3. Same thing again. How many 3's go into 72? Well, I could use a calculator, but I'm lazy and I don't feel like doing it. And I should be able to do mental math in my head, right? Why am I doing 72? Because all the decimal point does is just multiplied by 10. And since there's a factor of, I can put a factor of 10 in there and it's still not going to change anything. So I can think of it as 72 as opposed to 7.2. It's just multiplication by 10 with the decimal. So how many 3's go into 72? Would that be 24? For those of you that shrugged your shoulders, maybe you should use a calculator. Have all kinds back there. So 3 goes into 72, I end up with 24, but it's really going to be 2.4. So you end up with, let's see, that's going to be 48, 4.8. For the next one, I got 8.1. Well, I got to take 2/3 of it. 3 goes into 81, and I end up with what? 20 what? 27, or 2.7. Great. So now I take 2 times 27, which turns out to be 54, or 5.4. So there I have all of the distances along the medium to the orthocenter, or centroid, I should say. Not that bad. So, what I'm going to do here is I'm going to give you a little bit of time here, and I want you to go through and answer this question. Here we go. Now, they want us to use the centroid theorem to find the lengths of OD and BE. Who thinks they've got what OD is? Parker, you think you got OD? Okay. Do you know what to do? You don't. Okay. So if I go back here, and when in doubt, you can always go back into your notes, right? So I need to use this, right? It says it's got to be 2/3 of the distance. So I go back to my problem, now that I know that it's got to be 2/3, and it's got to be AD is 5, so that I know, right? And it's got to be 2/3 of it to go from here to AO. So I got 2/3. Last I checked, that's just going to be 10 over 3. But that gets me AO, doesn't it? Do I get the one I want? No. So if I know what AO is, could I take AO away from AD? So I could take 5 and subtract away 10/3, right? What do you mean, what? Yeah. Oh, okay. I'm beginning to see what your difficulty is here. Okay. So try it this way. What we need to do, I'm going to call that A, I'm going to call that O, and I'm going to call that D. This is where actually going and drawing things out and trying to put in as much information as possible. So we said the distance from A over to D was how much? That was 5. Now the rule tells us that if I take 2/3 of this distance, I get A to O, correct? So I take 2/3, multiply it by 5, and that equals 10/3, correct? So that tells me that the distance here is 10/3, or if you like, 3 1/3. I need to find the distance that goes in here from O to D. So if the whole thing is 5, I would subtract off 10/3 then, correct? Does that make sense? Well, I got to get a common denominator, so that's 3, and that goes to 15. Yes? 15 minus 10 gives me 5/3, or, if I like, 1 2/3. So that means the distance here is 1 2/3, or 5/3. That's the distance here. You cannot do this stuff in your head and just, oh, guess at it, think it's this or that or whatever, try something. We have rules for going through and doing the process. One of the things that you have to learn to do is actually draw them out and to pretend you're interested, paying attention, and following along. That always helps. So, I need to take care of BE now. The only information that they give us here is that E to O is 4.2. So I'm going to do the same thing I did before. Draw it out so I can see what it is that I am looking at. E is over here, and O would be right about here. So they say this here is 4.2. Now, if this distance here is 2/3, this would have to be 1/3. Is that correct? So isn't 2/3 the same as 1/3 plus 1/3? So that means the distance to OB would be what? 8.4. And so what would the distance from B to E have to be? 12.6. But this is what you need to do to make sure that you can go and figure these things out when you were working on them. So, I'm going to let it off there. You guys can begin on the assignment, and it's due by looking at the calendar.